Hey, Jack Davis here with DevSlopes.com, and I'd like to welcome you back for part 4 of our journey into protocol-oriented programming. In the last lesson, we covered the basics of protocol extensions. In this lesson, we're going to briefly dive into generics. Generics aren't strictly necessary for protocol-oriented programming, but they are used frequently, and I felt like this was a good place to introduce them. Generics are another subject that can be pretty deep, so this is just more of an introduction. As with protocols and protocol extensions, if you like what you see, I really encourage you to research these topics and try to grasp the concepts. Learning these subjects can make you a very desirable candidate to an employer. So let's jump in and take a brief look at generics. So we're going to go ahead and set up a new playground here. Get this on the right screen, and we'll just call this generics, and we'll leave it iOS, and I'll put it on my desktop. Alright, we'll get rid of this. And so generics, let's use a couple of examples here real quick, and then I'll lay out the case for generics. So let's say that we wanted to create a function that took an integer and added 1 to it. So let's say func, and we'll say int adder, and we'll pass in a number. It's an integer and returns an integer. And then we'll just return number plus 1. Alright, nice function. Just call it int adder and pass in, say, 15. Alright. So we see here that this works. We passed in 15, it returns 16. Alright. Now what if we want to do the same thing with, say, doubles? If we do int adder and pass in 15.0, we get an error because 15.0 is a double, it's not an integer. So to fix that, we could come back and we could say func double adder, pass in a number, and we'll say double and return a double. And then we'll just return number plus 1. Whoops. Now then, if we say double adder and pass in 15.0, we get 16 again. Alright. Now this is the problem that generics address. This is the problem we're solving with them. And basically, wouldn't it be nice to have these two functions right here? Just have a generic adder function that you could pass any numeric type into, and then it would turn around and know what you meant and return you a correct value based on that. That's what generics do. So let's just go ahead and dive in here. We're going to create a generic adder, and we're going to pass in, we've got to specify this here, and I'll explain it in just a second. Okay, so here's our function, and this may look a little weird to you. This T right here is just a placeholder. Basically, whatever type you pass into this right here is going to take the place of this T in this declaration here. This right here, the method that you pass in, or the value that you pass in, I put the stipulation here that it has to conform to the Stridable protocol. And then here's the actual number where we pass it in, and it's going to return a value of the same type that was passed in. So if you pass in a double, it's going to return a double. If you pass in an integer, it's going to return an integer. And if you're familiar, if you option click on this right here, this gives you the declaration of Stridable. And conforming types are notionally continuous one-dimensional values that can be offset and measured. And that's kind of what gave me the clue that this right here would be the protocol that I was looking for. And you can confine these generics to different protocols or different types, as we'll see some more here in a minute. But basically, you can command click on this, and it'll take you to the Swift Standard Library. And once we get in here, we see this is the declaration for Stridable. And you have to do a lot of looking around sometimes in the standard library and documentation to be able to find the right protocol or something to use for this. But anyway, Stridable was the right answer for this generic adder. So in order to call it, all we've got to do is just say generic adder, and see it gives us the placeholder there for the type. So we're just going to pass in 15. This is an integer. So once we do that, we see we get 16. And if we pass in a double, we still get 16. So this is doing exactly what we're wanting. We replace these two functions with one generic function. Okay, so that's the basics of how generics work. And you don't always have to constrain the type to a protocol, but there's a lot of cases where you need to. So let's look at another case here. Let's look at some functions. We'll say int multiplier. We're going to pass in two integers here. And then we're going to return, and this LHS and RHS just stands for left hand side and right hand side. And you probably see that quite often in code. Alright, so we've got an integer multiplier here. It's going to take two integers and it's going to return the product of those two integers. So in order to call that, all we got to do is just say int multiplier and pass in, say, 2 and 5. And that gives us 10. So that's exactly what we're looking for. But there again, we can't use this for doubles. So without generics, we have to do and we're going to return oops, I'm sorry. This should be a double. This should be a double, and it's going to return a double. Alright, so all we've got to do now is just say return left hand side times right hand side. And then we'll go ahead and call it, and we'll say double, no. Double multiplier, and we'll say 2.0 times 5.0, and we get 10. So how do we take these multiplier functions and do this generically? Well, it took me a little bit of research, but I think I found an answer, and it may not be the best answer because you have to extend the types that you want to be able to use with it. There's probably a different answer out there that may work out better. This is just what I came up with in the short amount of time I had. So first of all, we're going to create a protocol. And we're just going to call the protocol numeric. And we're going to add this function here for the multiplication asterisk. We're going to pass in left hand side as self and right hand side as self. And we're going to return self. Alright, now that we've got that protocol, we need to extend the types that we want to be able to use with this protocol. So we'll lay out some extensions here, and I'm just going to do, say, double, float, and integer. So we're going to extend that and add so that it conforms to that numeric protocol. And all we've got to do, we don't have to put any implementation code in here. All we've got to do is just conform to the numeric protocol in order to inherit or to gain this function signature here. And we'll add another extension for, let's say, a float numeric, and we'll do the same thing for an int. All right. Now then, we've got that. Now we need to actually create the function. So we'll do func, and we'll call it generic multiplier. And we're going to do our generic here, and this time, instead of stridable, we're going to constrain this to the numeric protocol that we just created. And we're going to do the same thing here. Left hand side takes a T, right hand side takes a T, and we're going to return T. And this T is just a placeholder. You could put whatever you wanted to in there. It's just like a label, or it's just a token that it gets replaced whenever the type's put in there. All right. So now all we've got to do is return left hand side times right hand side. And that should be all that we've got to do to get this to work. So let's do generic multiplier. And on the left hand side, let's pass in, let's just start off with a integer. So we'll say 5 and 5. All right, there we go, we get 25. Let's do the same thing. This time let's pass in a float. Let's say 2.2 times 5. But that's correct. So, yep. All right, so that's just kind of a brief, I know this last one was a little more complicated. Basically, I had to come up with my own protocol here and extend the types that I wanted to use with it, with this function, to conform to that protocol. And then on my constraint here for my generic, I constrained it to that protocol. So I hope that wasn't too complicated. But there's a lot of power here, and it gets pretty deep. And I really suggest that you research this and find out all you can on generics if you're interested at all. They come in really handy, and it cuts down on a lot of code. And it's nice to be able to take a function, instead of having to create 10 different functions for something, you can create one generic function and take care of all of it. And generics are used in a lot of places. So anyway, that's our generic lesson. I hope it was helpful. Hopefully one of these days we can put out some more advanced content on it and get a little deeper. But that's what we've got for our introduction to generics now. So anyway, thanks for joining, and looks like that's it on the introductory stuff. The next lessons we get into will be some practical examples of ways you can use protocol-oriented programming in your own projects. So I hope you stick around and watch those, and we'll see you next time. Later.